Hi, this is Dr. M. Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about potable water, specifications, treatment of potable water. Here, before going to the treatment of potable water, so how we can define potable water? Potable water is nothing but it is a water that has been treated and tasted and tested as safe for human consumption. That means water which is suitable for human usage is known as potable water. It includes tap water, bottled water, filtered water, and any other pure water considered as safe for drinking and food preparation. So, what are the important specifications of potable water? The water should be clear, odorless, and colourless. The turbidity should not exceed 10 ppm. The TDS levels for potable water should not exceed 500 ppm. So, here TDS means total dissolved solids. So, different types of salts and compounds present in water. That entire compounds considered as TDS. The TDS level should not be exceed 500 ppm. The hardness of potable water must be 125 ppm. And pH levels of potable water is 7 to 8.5. The water should be free from any heavy metals like lead, arsenic, chromium, manganese, and dissolved gases such as hydrogen sulfide and S4. This water should be free from all pathogenic microorganisms. So these are the important specifications of potable water. And next, coming to the different treatment methods of potable water. How we can purify the potable water? Potable water we can treat by following steps. First one is screening, sedimentation, coagulation, filtration, and disinfection. Let us discuss one by one. Steps involving treatment of potable water. That is, first one is removal of suspended impurity. Suspended impurities we can remove by following steps. First one is screening. So in this process, the raw water is passed through skins having large number of pores where floating materials are retained. After completion of screening process, water passes to sedimented tank. In this process, the water has to stand undisturbed condition in a big tanks about 5 meters deep when most of the suspended particles settle down at the bottom due to the gravitational force. Next one, coagulation. Sedimentation with coagulation is the process of removing fine suspended and colloidal impurities by addition of coagulants. Here coagulants are nothing but different types of chemicals we are adding to the water. Coagulant when added to water form insoluble gelatinous fricurants. Precipitate which descend through the water, absorb and entangles very fine suspended impurities, forming large frogs which is settled on easily. Here we can see some coagulants. Sodium aluminum oxide forms insoluble precipitate aluminum hydroxide, trioxide, and aluminum sulfate also we can use as a coagulant to form aluminum hydroxide insoluble precipitate. And in different types of RMs also we can use it as a coagulants. Here potash RM, K2SO4, aluminum sulfate and 24H2O, and sodium RM. So formula for sodium RM is sodium aluminate ferrous sulfate and 7H2O. So when you are adding RMs to the water, causes sedimentation. The sodium hydroxide thus produced precipitate magnesium salts such as magnesium hydroxide. You can see here magnesium sulfate when react with sodium hydroxide form magnesium oxide and sodium sulfate. After the coagulation step, water arose to filtration. It is a process of removing colloidal matter and most of the bacteria microorganism by passing water through a bed fine sand and other proper sized granular materials. A sand filter consists of a thick top layer, fine sand placed over post sand layer and grains. So here we can see the lapid sand filter. So it is provided with an inlet for a water and under drain channel at the bottom for exit filter water. Here we can see the inlet for raw water and it is the exit for treated water. Sedimented water entering the sand filter is uniformly distributed over the entire fine sand bed. So it is an entire fine sanded bed. So during filtration, the sand pores get clogged due to retention of impurities in the pores. The rate of filtration becomes slow. The working of filter is stopped and about 2 to 3 centimeters of the top fine sand layer is scraped off and replaced with green sand and the filter is put back into the use area. Next, removal of microorganisms. In this process, we can remove the different types of microorganisms present in the water. Disinfection. The process of destroying and killing the disease producing bacteria microorganisms from the water and making it safe is called disinfection. Boiling. Next method is boiling. Boiling the water 10 to 15 minutes. All the disease producing bacteria are killed and water becomes safe for use. And by adding bleaching powder. The purification is achieved by dissolve 1 kg of bleaching powder in 1000 kiloliters of water. This dissolved water produces a powerful germicide called hypochlorous acid. It produces disinfection action and kills the germs present in water. So here CaO₃, it is a bleaching powder. When you are adding bleaching powder to the water, form calcium hydroxide and chloride. chlorine react with water form hypochlorous acid. So here hypochlorous acid act as a powerful disinfectant. Once hypochlorous acid formed in the water, it can kill all the microorganisms present in water. Next one is chlorination. It is also a process of purification of drinking water by producing hypochlorous acid. When this chlorine mixed with water, it produces hypochlorous acid, which kills the germs present in water. So chlorine is a basic. That means pH value of chlorine is more than 7. So disinfectant and is much effective over the germs. Hence chlorination is widely used all over the world as a powerful disinfectant. We can apply the chlorine to the water by operator is known as chlorinator. By using chlorinator, we can purify the water. Next one, breakpoint of chlorination. Breakpoint of chlorination is the controlled process in which suitable amount of chlorine is added to the water in order to kill all the bacteria present in water or to oxidize entire organic matter and to react with free ammonia. The chlorine liquids should be appropriate. So breakpoint determines whether chlorine is further added or not. So it indicates again chlorine we had to add the water or not. So by chlorination, organic matter and disease producing bacteria are completely eliminated, which are responsible for bad taste and bad odor in the water. When certain amount of chlorine is added to the water, it leads to the formation of chloroorganic compounds and chloramines. The point at which the residual chlorine begins to appear as termed as breakpoint. So we can see in our diagram, it is a point of at which residual chlorine begins to appear as. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.